This is an oxygen atom, and this is a hydrogen atom, and these two atoms combine to form the V-shaped molecule that we all know and love, the water molecule. As we know, two atoms form a covalent bond when they share their valence electrons. The covalent bond becomes nonpolar when the shared electrons are near the middle of the two atoms, and becomes polar when the shared electrons are closer to one of the atoms, as is the case here. This unequal sharing of electrons and water's V-like shape make it a polar molecule, meaning that its overall charge is unevenly distributed. In water, the oxygen atom of the molecule has two regions of partial negative charge, and each hydrogen atom has a partial positive charge. The properties of water arise from attractions between oppositely charged atoms of different water molecules. To understand this, let's suppose there are two water molecules near each other. The partially positive hydrogen of one molecule is attracted to the partially negative oxygen of a nearby molecule. These attractions are called hydrogen bonds, and because they form and reform quickly, they are represented by dashed lines. It's important to note that a hydrogen bond, as its name suggests, includes a hydrogen atom and another electronegative atom, such as oxygen. Due to the oxygen atom having two regions of partial negative charge, it can form two hydrogen bonds with two hydrogen atoms within another molecule. Each hydrogen atom can form one hydrogen bond, which allows the water molecule to potentially form a maximum of 4 hydrogen bonds. Hydrogen bonds and water's chemical states. As we know, water exists in 3 chemical states: liquid, gas, and solid. When water is in its liquid form, its hydrogen bonds are relatively fragile, each being only about 1/20 as strong as a covalent bond. These hydrogen bonds form, break, and reform with great frequency, each lasting only a few trillionths of a second. In water's gaseous form, steam, due to elevated temperature, high kinetic energy, its hydrogen bonds are completely broken. This allows water molecules to be free from one another, and water gains gas-like properties. In water's solid form, ice, its hydrogen bonds are strong and robust due to low temperature, low kinetic energy, unlike the gaseous state, which makes the hydrogen bonds less likely to break and more capable of forming more hydrogen bonds at each instance. 4 strong hydrogen bonds form around each water molecule, allowing water to exhibit solid properties. This also represents the maximum number of hydrogen bonds that can be formed. The extraordinary properties of water emerge from these hydrogen bonds, which organize water molecules into a higher level of structural order. That concludes our lesson for today. Thank you for watching, and see you next time.